So today's webinar is on how to build a machine, and that's going to be for our simulation purposes. And we'll be able to follow along today with the tutorial that we have already built into the software program. So first we're going to make some toolpath so that we can view it in our simulation. So we're going to do the most basic thing possible here to get some toolpaths just to get simulation up and going. I'm going to go to the top and go to create 2D, and I'm going to make a rectangle. And I'm just going to make a 2x2 rectangle here. Click OK. So I've got a rectangle 2 inches by 2 inches, and I'm going to do a profile around it. So we're going to go to the top and go to CAM and start a new job. And we'll have the basic BC3X mill. That's our BobCAD 3-axis milling machine for milling. Go to our stock wizard, where we could define our workpiece. So if we have a finished 3D model, I could select the 3D model here as my workpiece to view in simulation as well. Make sure everything's cut to size. I don't have a 3D model, so I'm just going to go to the next page, where I have my stock right here. I'm just going to leave it alone, have it 2 inches by 2 inches by 1 inch for the thickness of my stock. And then our last page, our machine setup, I'm also going to leave that alone. It's just going to be right smack dab in the middle of the stock, on top of the stock there. And then I'm going to scroll down in the machine setup page and click OK. We can go back to a top view. And then I'm going to create a profile rough and a profile finish around it, just by going to my CAM tree, right-clicking on Machine Setup 1, and going to Mill 2 axis about halfway down the page here. I'm going to select my geometry. I'm going to window select the rectangle and click OK. My next page is my total depth, so I'm going down 1 inch, down to the bottom of the stock there. And that's really the only thing I'm going to change. I'm not going to change anything with the tool, parameters, lead in, lead out, anything like that. I'm just going to leave them at their default settings. So I'm just going to hit compute from here. The only other thing I have to change is the direction of the cut, because it's cutting on the inside of the profile of the part when I want it to cut on the outside of the part. So I do that by going to my CAM tree, and under the feature, right below geometry, we have this option, default change start point. Now, when I highlight that text there, default change start point, you can see that it's cutting counterclockwise, and it's compensating on the left by default. So all I want to do is reverse the direction so that it cuts clockwise and comping on the left so that it's on the outside. So I do that by right-clicking on default change start point and going to reverse direction. I click on reverse direction here. And then I right-click on the feature and compute the toolpath again by clicking on compute all toolpath, the third option from the top. And so now we've got a profile rough and a profile finish around a 2x2 square that we could view in simulation. Now, just for fun, let's see the simulation with the BC3X mill machine. So at the top, we go to Start Simulation. And you can see, again, as I mentioned earlier, the machine housing, the spindle, and the table, these are all going to be showing if you have your Machine Simulation Pro on your license. If you don't, you won't be able to see this in simulation. You can always upgrade to the Machine Simulation Pro if you need to. But again, we'll also be covering today how to set your limits to the machine. So at least when you try to simulate and post G-code, there would be an error if you have there would be an error if there is an overtravel in any of the axes, X, Y, Z, even A, B, or C rotational axes. All right. So let me know if you guys have any questions so far. Basically, we've just done a profile rough, profile finish. We went into simulation, and we can see the stock is sitting inside of the table. This is the first thing I wanted to highlight today, because And also, I forgot to mention, if you don't see the machine here, you can also go to the top, and in this drop down, you may have workpiece stock highlighted, which will only show you the workpiece in the stock. Tool, which will only show you the workpiece in the stock, but when you run simulation, the camera will be fixed to the tool. We'll sort of follow along as the tool moves along. And we want to change it to machine here up at the top left so that we are viewing the machine as well. And now we get into, okay, why is the stock sitting inside of the table like this? And when I hit run, why is the tool going down into the table with the stock here? The reason for that is because of our machine setup. So we'll close out of simulation. We'll go to the machine setup 1 under the CAM tree. Right click on that and go to edit, the top option there. Now we're not going to change anything with the coordinate system location. We're going to leave it at the center of the stock, on top of the stock. But what I'm going to explain it is that this machine setup is going to be on top of the table as well to start with. So to change that location in our simulation, we scroll down to the machine setup page down at the bottom, and we can see this work offset XYZ. So the thickness of the stock is 1 inch. So if I want to raise it above the table, I type in 1 inch in the Z direction here. I always mention that the work offset XYZ numbers here, when I change them, does not change anything in the G code itself. It only changes the position in the simulation. So if I raise the stock up 1 inch to get it 1 inch above the table, I click OK. I go to simulation, and then we'll see the stock on top of the table now. So if you set up a fixture, let's say you bring in the Kurt vise and soft jaws to hold this piece of stock in and things like that, you'll want to raise it up even higher so that your fixture can be in between the table and the stock here as well. All right. Let me know if you guys have any questions so far. We've just gone through basically setting up a 2-axis mill operation, profile, rough, and finish. We went into simulation to see how to view the tool profiling around the stock here. And now we'll build our own machine to see in our simulation. And we're actually just going to follow along the article to begin with that we have built into the software program so that you can follow this tutorial at a later time. So we'll go to the top and we'll go to File, and we'll go to Help. Now you'll see BobCAD-CAM Help, Getting Started, Tip of the Day, all of these options. At the very top, you'll click on BobCAD-CAM Help. That will launch basically our, basically a manual to our software program. So I'll move that over to my screen here that you can see. Over here at the top right corner, you can see you can click on these 3 bars here, and it will load the chapters of the different topics that we have. So this has an explanation of every single CAD and every single CAM operation in BobCAD. So if I don't know how to create a rectangle in BobCAD yet, I can go to CAD, I can go to Create 2D, I can go to Shapes, and I can go to Rectangle. And this rectangle center is the one that I usually create a rectangle with. So then it tells me what this rectangle center function does. And then when I scroll down, it gives me an explanation of everything that's in the rectangle function. The dimensions, what is length, what is width. I had a customer ask me yesterday, what is angle? Angle allows the rectangle to be rotated around the origin. So it will give you an explanation of everything that's in every CAD function and every CAM operation in this help topic page. Now, there's also a search box. So in the search box, I'm going to type in machine build. Actually, I think I can just do machine. I'm just going to type in machine and hit enter. The first result that pops up is how to create a machine. So this is the article that we're going to be following along today. It gives the introduction. This tutorial explains how to create a machine and will provide links to related topics. Machine creation. Machine creation starts with a machine definition to define each element of the machine, such as the linear and rotary axes. I'm not going to read all of this, so you guys can read it at your leisure. But basically what it's explaining is that the components to the machine here are geometry that are built with STL files, and they can be used for the simulation, and also you can set your limits to the machine so that in the G-code program, before it posts the G-code program, it will make sure with those limits that you set that there's no over travel. All right, and then the following shows the machine definition tree that defines the 4-axis machine that is created in this example. The machine definition tree and the machine that we're going to be creating today. And we'll be seeing a lot of this later on, the machine definition tree. We're going to be getting into that a lot. Now it's saying how we're setting up the table and setting up the spindle in the z-axis for the z-axis element and things like that, setting up the like a cylindrical part for the rotary axis. All of these parts are in this BC4X mill already. So we're basically going to copy and paste it from there. So here are the steps. We start with step 1. Step 1 is add a new machine. So in the CAM tree, now I hope you have this article pulled up because I'm going to move it to my other screen here. And we'll follow along with step 1. So we're back in our part file of BobCAD-1 with the 2x2 square and the profile rough and profile finish. And we start with part 1. Add a new machine. In the CAM tree, right-click CAM defaults and click current settings. That'll be the third option down. The current settings dialog appears. The default page, machine parameters, should be active. In the machine group, click add. So you'll see machine, it'll say make will be BC3X mill, unless you have defaulted a different machine already. And then right in between there, you'll click add. The add modify machine dialog appears. In the add modify machine dialog, next to machine name, type the name of the machine. We're naming it 4-axis example. It's going to be a milling machine for the type. You can see all the other machines that we can create: laser, plasma, water jet, lathe, wire, and mill turn, which is a lathe with live tooling. We're just going to select milling for this one. And for the axes, we're going to select 4-axis machine. You can see that we can also make a 5-axis machine, whether it's head would be where the spindle could rotate around 2 axes. 5-axis head table is where the head, the spindle, could rotate 1 rotary axis. The table could rotate 1 rotary axis. And then table machine, which would be where the table could rotate maybe like around the platter, which would be the C-axis rotation, and then around either A or B for a trunnion. So we'll go to 4-axis machine and click OK. And then you can also see other parameters on this page, like maximum number of tools, rapid feed rate. So in our simulation, it'll reference this rate here, so that when there's any rapid moves in simulation, it will calculate based on the feed rate here, the cycle times. Maximum spindle speed. So when you're on your tool page for every milling operation under a milling job, if you set your spindle speed a higher number than this, or if you set your cutting feed rate a higher number than this number here, it will limit the number to these numbers here. So it's not going to exceed the numbers that you have. Maybe if you accidentally typed in 6,000 for your feed rate, but your maximum cutting feed rate is only 600, then it'll limit it back down to 600. All right, now we're on to part 2, locating. I'll move this over for a second. Now we're on part 2, which is Locating the machine definition files. When you create a new machine, a folder is automatically created along with an XML file of the machine definition in the BobCAD-CAM data folder. The default location is under your C drive, and we're going to find this file path right now. This is the same location in which the geometry files for the machine must be stored. So we're going to gather all of the part files under the BC4X mill machine, copy and paste it into the one we just created, our 4-axis example machine. So down at the bottom of your desktop, you should have an icon of this manila folder labeled File Explorer. If you don't find this one, you can always click on your Start button down at the bottom left corner, and you can type in File Explorer here and open up that application. This is where you can find files that you can open on your computer or move them around wherever you want, from your desktop to your downloads or any other folder. So we're going to find the folder that we just created with our 4-axis example XML file in that folder already. Now that is found on the left-hand side. We'll go to this PC, should be down towards the bottom of your options here. This PC, and then you'll see OS and in parentheses C:. That is your C drive to your computer, where everything's stored on your hard drive here. So you'll double click on that on the C drive. And then you'll find, if it's in alphabetical order, you'll see BobCAD-CAM data up towards the top. You'll double click on that folder. And then you'll double click the subfolder BobCAD-CAM version 37, or whatever the current version of BobCAD you're working in. And then you'll scroll down and you'll find this folder labeled MockSim. That's how we pronounce it. It stands for machine simulation. So for whatever reason, we abbreviated it and pronounced it MockSim. So we double click on this MockSim folder. And then up at the top, you can see 4-axis example. Again, if it's in alphabetical order, you just click on name to sort it by order of alphabetical order. And then you'll find 4-axis example up at the top. When you open up that folder, you'll see only the XML file. And I think that's just going to be text if you try to open it up. It's basically just saving the information of the limits of the machine and other things like that. So we're not going to mess with that XML file. We're going to mess with all the other part files. So we're going to move the components of our BC4X mill into this folder here. So we're going to back up one folder. You can see up at the top we have MockSim. I'm going to click on that. So we're back to the MockSim folder with all of our other machines that we have built into the software program. And we'll scroll down and we'll find BC4X mill. There it is. So we'll double click on that one. Now you'll see BC4X mill as an XML file up at the top. We want to copy everything else except for that one. So what you could do is you could window select all of them like this. And then you're going to hit Control-C on your keyboard to copy. Or you could right click on these guys and go to copy. Then you'll back up one folder, back to MockSim. You'll go up to the top and find 4-axis example. Open up that folder, and then paste those files into this folder here. All right, let me know if you guys have any questions so far. We've gone to this file path from the computer under C drive, BobCAD-CAM data, BobCAD-CAM V37, MockSim, and 4-axis example to bring in all these STL files from our BC4X mill into our new 4-axis example machine. I'm going to minimize the File Explorer for now because we may have to go back to this folder sometime later on. And then we'll go back to our tutorial here. Locating the machine definition files, I think we've done all of this. Open the BC4X mill, Control C, go to 4-axis example folder, Control V to paste. These files are now available to add to the machine definition page. Important, when building your own machine, you must place the STL files for your machine in the folder that is created by the software, as explained in the previous steps. So, just saying, it's important that you did what we just did. Okay, now we're on part 3. The machine definition dialog box define the y-axis parameters. So we're going to define all of the components that move in the y-axis. Then we'll define all of the components that move in the x-axis. And then we'll define all of the components that move in the z-axis, which is the spindle, moving up and down for your depth. All right, so here we go. Part 3. We are back in BobCAD, and we're back in this current settings page under machine parameters. If you're not there, again, it's under the CAM tree. We right-click on CAM defaults and go to current settings. And then we select the make of the machine, which is our 4-axis example. And now we're on part 3, the machine definition dialog box. Define the y-axis parameters. On the left side of the current settings dialog box, click machine definition. So we're in machine parameters now. The next one down, machine definition, is the one we'll click on. Notice the machine group in the middle of the dialog, where it says 4-axis example, then it'll say Y below that, then it'll say X, then it'll say A for our rotational axis. Notice the machine group in the middle of the dialog. The machine tree shows all of the machine elements that have been automatically created. This definition includes the linear axes, the rotational axes, and the dynamic holder and workpiece elements. We'll get into that sort of at the end here. All right, the items in the tree are used to define or modify the parameters of each component. For example, in the tree, click Y. So right under 4-axis example, you'll click on Y here. You'll notice on the right in the machine data group, the parameters for the Y-axis display. The direction and the limits for the Y-axis must be defined. The machine being built requires the vector to be negative. Confirm the direction vector values are x0, y-1, and z0. And this is a good note here as well in this tutorial page. Note the vector direction for the axes is determined by the type of machine. For machines in which the table and not the head moves in x and y, generally these values are negative. For machines where the head or the tool moves in x and y, generally these values are positive. The direction is determined by the relationship of the machine elements and which way they need to move to make the tool move in a positive direction in each of the x, y, and z axes. So a little more of a layman's terms of it, or basically explaining this, why it's negative here, why the y is negative, is because the table is moving. So if you could imagine these, if you could imagine this machine right here, here's the spindle, and if the spindle's moving, it's freely able to move in positive x, and is freely able to move in positive y. But what if our machine is set up where the table moves and the spindle stays stationary? Well, the tool isn't moving in positive y. The table is moving so that the tool can move in positive y. The table is moving in negative y, so that the tool moves across the part in positive y. So that's why we would have our numbers in a negative number rather than in a positive number. That's the concept there. Under limits, to the right of the minimum, click on the box. So we're back here in our current settings here. Under machine data, the limits for minimum, you can type in the minimum limits to your machine. For this example, type 10. So we're, negative 10. So for the minimum, it's always going to be either 0 or a negative number. So we'll type in negative 10. So the tool's not going to be able to travel anywhere further than negative 10 in the -10 in the y direction. And then below that you have max, and we'll change this number to 10. So our limits in the y-axis now are positive and negative. I'm sorry. The limits in the y-axis, I keep saying x. So the limits in the y-axis now are positive and -10. So if we sketched a rectangle out here instead of 2 by 2, let's say we made it 12 by 12, and we try to do a profile around it, and then try to simulate and post it, it'll give us an error saying, whoa, hold on a second. With this machine that you have set up, in the y-axis, your limits are only positive and -10. You either have to maybe center your square a little bit better so that you go +6 and then -6, or change your limits here if your limits can be exceeded a little bit further than that. Alrighty, so we are down to the initial value is going to be set to 0. This sets the initial position to the origin or 0 location of the y-axis. So we always leave that at 0. All right. Now we are to part 4. Define the x-axis parameters. So same kind of concept there. Our table, so I click on x right below y, and our table is going to be moving. So we're going to leave this x direction at -1. Then in the limits in the x-axis, I'm just following the tutorial here, and it's telling us the minimum we want to set in x is going to be -29. And next to max, click in the box and type 11. And then our initial value is going to be 0. Part 5, define the a-axis parameters. So if I click on A below X here, you'll see the direction in X is positive, a +1. So it'll rotate in a positive number there, or in a negative number if it needs to rotate in the negative direction. There's nothing that needs to be flipped with that option there. And then under limits, you'll see a minimum of -10,000. Right? Is that 10,000? Yep. And then a maximum of +10,000. So what those numbers will do is it will, if we're doing a 4-axis operation, let's say we're doing a rotary operation, and the cylinder is continually spinning around, and every time it's a full revolution is 360 degrees. So if it does enough revolutions and it goes past 10,000 degrees, what the simulation will do and what the G-code will do is the tool will retract, the cylinder, the rotary table will rotate back to almost a -10,000, so that you have an extra 20,000 degrees to work with. That's normally for older machines that aren't able to go past a certain number for your a-axis rotation number there. All right, so we're leaving that alone, and then we're getting to part 6. There's only 14 parts, so we're almost halfway done. All right, part 6 is define the z-axis parameters. In the machine group, click Z. So that's the next one down. To select the linear z-axis. Notice the direction is defined as x0, y0, z1. This defines movement along the z-axis. Under limits, next to minimum, click in the box, and I'm just going to highlight all of it like this and type in -7. So this is going to be, instead of -15, we're typing in -7. And next to max, instead of +15, we're going to type in +18. Next to initial value, oh, this is one that I didn't do last time. Interesting. Next to initial value, click in the box and type 18 instead of 0. So essentially, the tool will start 18 inches above, and you can see the example here of what that looks like. Next to initial value, click in the box and type 18. The spindle, or the tip of the tool will be 18 inches above our stock now. All right, cool. Adding geometry to the machine definition. This is where we get into the pro simulation only. So if you don't have pro simulation, you don't need to add geometry because you won't see it in simulation. At least you have gotten to the point where you've set your limits to your X, Y, Z, and your A-axis rotational axis, so that when you go into your simulation or when you go to post the G-code, it will error out if you have an overtravel. All right, adding geometry to the machine definition. Let's read along here. Important, the Pro simulation is included in the 4-axis Pro, 5-axis Standard, or 5-axis Pro modules. If you do not have Pro simulation, do not add geometry, as shown in parts 7 through 11 of this tutorial. The Standard simulation does not include the full machine simulation, so it does not use the geometry files for simulation. The following image shows all of the individual geometry files, STL files, together in one workspace. This is shown to help you understand how each geometry item is aligned in the graphics area when creating the geometry files for the machine. In the second image, the view is made transparent and zoomed in to show the coordinate system used to align the machine elements. So that's a really good point. When we go in, I think a good step here before we get into adding the part files to the machine. We're here in BobCAD. What I'm going to do first is I'm just going to open one of these STL files to see what they look like. So let's close out of the current settings page for now. We're going to close out by clicking OK down at the bottom. Okay. And then we're going to go to File. We're going to go to Open. And we should be in, well, maybe not. I don't think we're going to be in that folder, the mock-sim folder that we want to be in. So we go to this PC. We go to the C drive. We go to BobCAD-CAM Data, BobCAD-CAM V37, or the current version you're in, and then open up the folder mock-sim. Go to 4-axis example, and let's open up the top one here, BC4X Mill Rotary X Base. Double click on that. We're going to be in inches for the STL file unit, and we'll click OK. Now when I rotate it around, this is the base that we're going to be importing first to be able to view in our simulation. And you will see, just as mentioned in the tutorial, that coordinate system is relative to the CAD origin location here as well. So we want to make sure when we model our parts, we're making sure that this CAD origin location is the reference point that is being used in simulation also. So when you see the other part files, like when you see this was the machine housing that we just saw, and you'll see like the table and the spindle and things, those will be oriented in each STL part file as if this CAD origin location is the origin location in our simulation. So the spindle is going to be above the Z-axis. When you open up that STL file, when you see the table, it's going to be down below the Z-axis, things like that. Okay, cool. So next, after adding all of the geometry files to the machine definition in the following steps, the machine tree looks similar to the following, similar to this file here, this image. All right. Oh, and the machine tree will look a lot like this. So we're going to scroll down, and we are on to part 7. We're halfway there. All right, so part 7, add the machine-based geometry. So we're back in BobCAD 1 with our 2x2 square with a profile rough and finish. And we're going to go back to CAM defaults, right-click on CAM defaults and go to current settings, the third option down. We're going to select the make of the machine. Should be at the top, 4-axis example. And then over on the left-hand side, we'll click on machine definition. All right, now we're on part 7, add the machine-based geometry. When creating geometry, the files must be saved using the STL file extension. Luckily, all of these files are STL files already. All right, step 1. In the machine group, right here, right-click the top tree item, 4-axis example, and click Add Geometry. Third one from the bottom here. Click on Add Geometry. In the open dialog box here, navigate to the 4-axis example folder, which is where we should be at, and select BC4XMill rotary X underscore base STL file. So we're going to find BC4XMill rotary X base. So I think these are all going to be in alphabetical order based on how we select them. So if you sort them by name, up at the top you'll see BC4XMill rot-x underscore base. So you'll just click on that file and click Open. The geometry item is added to the tree. In the tree, click Geometry so it is selected. So you'll see Geometry right below 4-axis example. You'll click on that, and over on the right-hand side, you'll see in the machine data a bunch of information about the geometry file here, the STL file. In the machine data group, next to ID, click the name Geometry and change the name to MH, that stands for machine housing, MH underscore base. I can name it whatever you want there, but I'm following along the tutorial so that everything makes sense here if you decide to go through this later on. Because the prefix MH, machine housing, was added, the visibility of this item can be changed using the machine housing view toggle in the simulation. Interesting. So MH is very useful here because in our simulation there's an option to view or hide the machine housing. So you could view or hide this model specifically in our simulation. Where did we get to here? Step 4. Notice the remaining parameters for the geometry item in the machine data group. The parameters for the added geometry can be modified from this location. For example, if you needed to change the STL file, in the left column, click Geometry. In the left column, click Geometry here, and then you could click on these 3 dots to change the STL file after the fact. For visual reference, the base geometry file is shown next, so it should look something like this. The STL file that we opened up before. Part 8, add the y-axis geometry. I'm going to show this again here. Part 8, add the y-axis geometry. We will add this y-axis base and this x-axis base here. We don't see it yet under x. There should be nothing under x. I'm sorry. There should be nothing under y except for x right below it for now. All right, step 1. In the machine tree, right-click on Y and click Add Geometry. Just like we right-clicked on 4-axis example and added geometry, now we're going to right-click on Y and add geometry. The one that we're going to open for this one, okay, I lied. It's not the second one down. It's going to be 1, 2, 3, 4, 5, 6 down in alphabetical order. The next STL file we're going to open is BC underscore 4X underscore mill underscore rot dash X underscore Y axis base. They're going to click on that STL file and open it. The geometry item is added to the tree. In the tree under Y, left-click on Geometry so it is selected. In the machine data group over on the right, next to ID, click on Geometry, click on the name Geometry, and type Y-axis base. All right, let's look at our steps here. In the machine data group next to ID, select the name geometry and type y-axis base. Warning, while adding spaces is acceptable for geometry items, it is not acceptable for the axes themselves. So if you rename X or Y or Z to something like X with a space and a 1, you would need to enter X_1 spelled out to avoid spaces and numerals. So I don't think you're going to be needing to change the IDs for the X, Y, Z, or A-axis rotation. But if you did, that's a good warning to come up to show you. If you highlight the Y-axis here and you change the ID right here, you want to make sure there's no spaces in this one and that there's no numbers in it as well. This has to be letters. It can be underscores also. All right. Step 4, click color. All right, so when we're under y-axis base now, you can see color. You can click on color here, and to the 3 dots, we're going to change the color that we will see this component in our simulation. So we click on the 3 dots, and let's make this a nice gray color down at the bottom right here, the third icon from the corner, this gray color, and click OK. When you run simulation, the y-axis base will be shown with the selected color. Step 5, in the machine tree, right-click on Y and click Add Geometry. So we added y-axis base, now we need to add x-axis base. So we'll right-click on Y and we'll go to Add Geometry. And in the open dialog box here, select BC4X mil rot x_x-axis base. So that's going to be this one here, 1, 2, 3, 4, 5 down from the top. BC_4X_mil _rot -x_x-axis base. So I can highlight it and click OK. The geometry item is added to the tree. Click on geometry so that it's highlighted. In the machine data group over on the right hand side, next to ID, click on geometry and you can delete that out, and we're going to name that one x-axis base. Set the color used for the base. Let's go with, just so we can see the difference between them, let's do the top left corner, this light red color, sort of pinkish light red color here. And then we'll click OK. Nope, sorry, not clicking OK. Sorry, that backs us out of there. If you did click OK, sorry about that. You just go back to CAM defaults, and we're going back to our machine. Go into current settings, go to 4-axis example, and then go to machine definition. I know it's a little bit complicated there, but we're back to the x-axis base and the y-axis base here. Okay. All right, now we're on part 9. Add the x-axis geometry. So y-axis geometry should look like this, y-axis base and x-axis base. I think we may have it flipped here, x-axis, y-axis. That's okay. It's not, as long as they're both below y, then it's okay. They can be switched around. X-axis geometry, we're making table and we're making rotary base here. All right. Step 1, under part 9. In the machine tree, right-click on X and click Add Geometry. In the open dialog box, we are searching for BC4X mil rot x_table. So that's the fourth one down. BC_4X_mil _rot -x_table. I'm going to highlight that one and click OK or open. The geometry item is added to the tree. Click on geometry to highlight it. In the machine data group over there on the right hand side next to ID, select geometry, and we're renaming this one table. Set the color for the element. So let's change this one to a dark red color and click OK. Next one down, click Reflect Map. So that's after transparency, after reflectivity, after geometry. At the very bottom here, Reflect Map. On the right-hand side, click on the three dots button, and then you should see only one file labeled Table Reflection. So this will have this kind of wavy pattern to the 3D model in our simulation to see that. So you'll highlight that one and click Open. This is a bitmap file. So you can select bitmap files to view to see a certain pattern to a 3D model as well here. For visual reference, this is the x-axis table geometry file is shown next. This is going to be what we see in simulation in the dark red color that we just added. Okay. Number 6 in the machine tree, right-click on X and go to Add Geometry. In the open dialog box, and now it's a little bit different with the listing here. Now it's got icons instead. So I think we can change that. Go to Show Previous. No, Show Preview Pane. More options. Here we go. Let's go back to a list. When I drop down this icon with the 4 lines, the drop down, I went to details so that we're back to the list like we were at before. All right. In the open dialog box, select BC_4xMil_rot-x_rotary_base. And that is found. Is that the second one down? These files are named so similar, it's hard to figure out which one's which. BC_4xMil_rot-x_rotary_base. Yep, so if you're in alphabetical order, just click on name up at the top here to see them in alphabetical order. It will be the second one down from the top. And we highlight it and click OK, or Open. Then you'll see geometry under the X option here. So you highlight geometry. In the machine data group, next to ID, click on geometry to delete that out. And we're naming it rotary base. Set the color for the rotary base. Let's do a different color here. Let's do all of them different colors so we can see which one's which. Let's do this really bright green color here so that we can see that one. For visual reference, the rotary base geometry file that we just created is going to look like this. It was going to be bright green. All right. Now we're on to part 10. Add the A-axis geometry. So we've done X and Y. Now we're going to do A, and then we're going to do Z, and then we're going to see our simulation. All right. Add the A-axis geometry. Under A, we'll have rotary table. So in the machine tree, right-click on A, and click on Add Geometry. In the open dialog box, select BC4xMil, rotary X, rotary face. So that'll be the third one down, rotary face. The last 2 words are rotary face for this file. Highlight it and click Open. And then under the A-axis rotation, you'll highlight geometry. And then over on the right-hand side, next to ID, you'll delete out geometry, and then you'll name it rotary table. And set the color. Let's make this one yellow. Running out of colors here. All right. Next, what do we got? Set the color, and visually, for reference, this is what the file is that we just brought into our simulation. Part 11, add the z-axis geometry. In the machine tree, right-click on Z, and it's down here towards the bottom. Right-click on it, and we'll go to Add Geometry again. The file we're opening for this one is BC4XMill rotary X _ z-axis spindle. Z-axis spindle will be the third one from the bottom. Z-axis spindle. And click Open. Highlight Geometry under Z. And then over on the right-hand side, you can delete Geometry for the name and name it Spindle. And let's change the color here. What do we have for a color? Let's go blue. That's a really dark blue. All right. For visual reference, the geometry we just selected looks like this for our spindle. And then we're on to part 12. Now, part 12, we're not going to change anything for necessarily. We're just going to highlight this information, just go over it, and then we'll go to our simulation and see how our machine looks that we brought in. Part 12, about the dynamic elements. The dynamic elements are the elements that can change with each program. The workpiece transform contains the first set of dynamic elements in the tree. This transform includes the toolpath, initial stock, the stock after it's been machined, fixture, and the workpiece. Generally, you do not have to define geometry for each of these items because they are defined by each program that you create. So when you go in the milling job and you define your workpiece and you define your stock and you create toolpath, that's what these are referencing. All right, and then part 13 is about the collision check. At the bottom of the machine tree, there will be an item labeled CC. This is the collision check that is automatically added to the tree when you created the new simulation. When you created the new machine. This item defines the machine elements that are included in the collision check. If the items defined in the collision check do collide during simulation, the collisions are reported in the Report tab of the simulation window. So if you highlight CC right here for collision check, you can see that in the first group, it's checking the collisions between the tool and the stock and the workpiece, and group 2 is the tool. So if you wanted to add any other collisions, maybe you wanted to make sure that the table is also not going to have a collision between the tool and the table, you could add that into one of the groups or anything else. All right, so we are good to go. We're going to click OK down at the bottom of our current settings, and we're going to check our work here by going to the milling job. You're going to click on milling job. Let's right-click on milling job and go to simulation, the 6th one down. Click on simulation to open it up, and we'll see how we did with our machine. Whoops, our machine is still the default BC3XMill. So let's close out of simulation. Let's make sure we have selected our machine to view in simulation. We'll see here BC3XMill. I'm going to right-click on that and edit. And then in the drop-down up at the top, we're going to select 4-axis example. Click OK. And now, moment of truth, we're going to click on Start Simulation and see how this looks. Should be a bunch of different parts with a bunch of different colors in here. Awesome. All right. We've got our machine housing base, which is this teal color. Up at the top, if I turn off machine housing, hide that, you'll see that the machine housing hides because we named it MH for machine housing in the file name. Then you've got your spindle in the dark blue. You've got your table files in gray and this red color. You've got the rotary table with in yellow and the fixturing for the rotary table in green here. And then we've got our stock here, this square block right here. So then again, if I'm doing a 4-axis milling operation and it's fit into the spindle here, I can move the stock in here. Let's say we want to move it over in the negative X direction so that it's away from the rotary table so that the spindle here doesn't run into it. We close out of our simulation, and then we can move the stock again by right-clicking on Machine Setup 1. We go to Edit, and down at the bottom, we'll move it over. Let's make a big number here. Let's go negative 10 inches in X under Work Offset XYZ down at the bottom here to shift the stock over in our simulation. So Work Offset XYZ should have X negative 10, Y 0, Z 1. And we click OK, and then we start our simulation again. And now we've shifted the stock over 10 inches away from our rotary table like that. So if you've got your cylindrical piece of stock and you need to move it out of the rotary table further or move it into the rotary table, that's how you can move the stock around like that. All right, we've created our first machine. Let me know what you guys think in the comment section. Was that easy enough to follow? Did you get hung up anywhere along the way? How complicated do you think it is? Do you think you could do it on your own yet? If not, you can follow that tutorial again under the Help Topics page. Again, that is labeled How to Create a Machine. So if you go to BobCAD, we close out a simulation now. We go to File, we go to Help, BobCAD-CAM Help, and then we type in how to build a machine in here. Should be at the very top, how to create a machine. And we followed this tutorial step by step to get the machine looking something like this with all the multicolors in it. All right, so we did the 4-axis mill with the tutorial. Let's try to do it on our own with the 3-axis mill here. So we'll do the same kind of steps here. I'm going to close out of our simulation. I'm going to close out of our tutorial, the Help Topics page, and we'll do it live. Let's see how we can go about creating a 3-axis milling machine. So we did 4-axis example here. Let's do 3-axis example. You guys are still following along. I give you guys credit because I know it's very complicated and probably difficult to follow along. So kudos to you guys. We're going to be doing another machine now, and it should be a little bit easier because we're only doing 3 axes now. We're not going to do the rotary table and all that kind of stuff. All right, we're starting from scratch again. Instead of 4-axis example, we're going to make a machine named 3-axis example. So again, we're going to go to the CAM tree in our BobCAD1 file with the square. We're going to right-click on CAM defaults, and we're going to go to current settings, the third option down from the top. Now from the machine and the make here, we're going to click on add, and we're going to name it 3-axis example. It's going to be milling, and it's going to be 3-axis machine for the axes, and we'll click OK. Now again here, we can set the number of maximum tools, we can set the rapid feed rate for our simulation runtime, we can set the maximum spindle speed and cutting feed rate to make sure that if we accidentally type in the numbers higher than those, then they'll be limited to these numbers. All right, and then over on the left-hand side from machine parameters, we're going to go to machine definition, where we have our Y, our X, and our Z. Now, before we move any further, we have to load those files into the mock.sim folder. So again, down at the bottom, hope you guys have that File Explorer minimized, so you can just reopen it here. And we're in our 4-axis example folder. If you don't have it minimized, you've got to reopen File Explorer. We'll go back to the file path from the beginning. It's under this PC, C drive, BobCAD-CAM data, BobCAD-CAM v37, and mock.sim. So in our machine simulation folder, you'll see up at the top now you have 3-axis example that we just created. So you'll double click on that folder, and you've only got the XML file first. Let's bring in all of our files from the BC3 XML, because we haven't modeled anything yet for the components. You could do that on your own time, but just look at the STL files that you have in the BC3 XML to see how that looks. So we go back one folder to MockSim. We scroll down to BC3 XML and open up that subfolder. Now we're going to select everything except for this XML file here. Now here's a good way to select everything except for this one. I'm going to window select all of them here. And now when you hold Control on your keyboard, you can add files or you could remove files from your selection here. So hold Control and click on BC3 XML file to deselect that in your File Explorer here. All right, and then you're going to right click and copy. Then we go back a folder to MockSim. Scroll up to the top where you have 3-axis example. Right click and paste. So now we've got all of our part files in here to select for the machine. I'm going to minimize again. We might need to go back to that folder some other time. So minimize File Explorer. We're back into BobCAD. Now we're going to do the same thing as we did with our. And do the same thing that we did with our tutorial. I'm going to pull that up just so that I can have a reference, make sure I'm doing this correctly. All right, how to create a machine. So we're back in the current settings under machine definition. Oops, no. After we selected our 3-axis example, under machine definition, we start by, let's start by doing the limits. So we go to highlight Y. Let's do minimum and maximum for our limits here. Let's do whatever you want to do for your machine. I'm going to do -20 and +20 for the limits in the y-axis. I'm going to highlight X under the machine page here. And then over on the right-hand side, limits, I'm not very creative. Let's do -20 for the minimum and +20 for the maximum. And then for Z, let's do the same thing. -20 for the minimum and +20 for the maximum. That minimum limit can be really useful for the Z limits. Let's say you can only go down 2 inches, right? You want to do -2 for your minimum limit there. And then that way, if you post out G code that's further down than -2, it'll error out and say, hey, you don't want to plunge the tool down that far. All right. Now we're going to, after we've set our limits, then we set the parts so that we can view them in our simulation. So first we right-click on 3-axis example up at the top here in machine, in the machine page. So 3-axis example, right-click on that and go to Add Geometry. Third one from the bottom. And the geometry file is not going to be in our 4-axis example. We're going back to the MockSim folder here. And we're going to open 3-axis example. And this one is going to be, what is it, mill base? I think that's X base. If you're unsure, you could always open the STL file in BobCAD to see what it looks like to make sure that's your machine housing. But we're going to do 3x mil x base for this file here. So I'm going to double click on 3x mill x base. And then I'm going to highlight geometry under 3x example. And I'm going to name it MH underscore base. I'm going to say this again because the prefix MH underscore was added to this name under ID. The visibility of this item can be changed using the machine housing view toggle in the simulation. Just like we did in the 4-axis machine, I was able to hide or show the machine housing. You want to make sure it's MH underscore here for your machine housing file so that you could show or hide it. All right, next step, add the y-axis geometry. So again, we highlight Y, we right-click on Y and go to Add Geometry. And this one is going to be Y base. Select Geometry, highlight Geometry under Y, and then change the name of Geometry to Y-axis base. Next step, we're going to go to X-axis base. I'm going to leave everything as this teal color. If you want to change the colors to gray or what have you, again, you can just click on the color here and click on this 3-dot button to change the colors of each of your STL files that are loaded in for your simulation. So next one, X-axis geometry. We're going to right-click on X. Right under Y-axis base, we're going to right-click on X and go to Add Geometry. And then this one, I think we're doing just table. So let's do 3-axis mill table and click Open. We're going to highlight geometry so that over on the right-hand side, we can rename it from geometry to table. And change the color if you want. See if we have a bitmap file for this. Yeah, we do. So for the table, we have a bitmap file just to change the reflection of of how the 3D model looks in simulation. So we'll click on this 3-dot button down at the bottom where it says Reflect Map. I highlight that and then click on the 3-dot button and then select Table Reflection and click Open. And then next, we don't have an A-axis geometry, but we do have a Z-axis geometry. So we'll right-click on Z and go to Add Geometry. And then we'll select 3x Z-axis spindle file. Click on that and click Open. Click on Geometry below Z, and then rename it from Geometry to Spindle. And I think that's all we need here. Let's see our progress. So we'll click OK. And now it asks, do you want to apply these machine changes to the corresponding job? Yes. But it doesn't change our machine. If you look at it in the CAM tree, we still have 4-axis example. So let's change it to our 3-axis example. Let's right-click, go to Edit, and under our drop-down, we'll select 3-axis example, click OK, and then check out our simulation. Click on Start Simulation up at the top of BobCAD. Okay, everything's good except for the machine housing. Not sure what that was about. Actually, I do have a good idea what it's about. So let's turn off the machine housing to see what file that was that we imported. It wasn't really much of anything. Oh, it was this right here. It's only, a table that's sitting inside of the table. So let's close out of simulation. Here's a good way of modifying the machine after the fact, modifying the components to the machine. So let's go back to the CAM tree. right click on CAM defaults, go to current settings. I'm under 3-axis example, and then I go to machine definition. I click on mh_base, and I'm just going to change the STL file. So it's not xbase that I need. Kind of a misleading name there. But I'm going to highlight geometry over here, and then I'm going to click on the 3-dot button to change the file that I'm referencing. And it's just going to be mh_3x_mil base. So I'll select that one and click open. That one sounds promising. And then I'll click OK. Do you want to apply these machine changes to the corresponding job? Yes. Now let's see what we have in our simulation. And that looks better. So congratulations, you've built a 4-axis milling machine and you've built a 3-axis milling machine, and you can see the different components that are being referenced for each part. Now we can show and hide the actual machine housing there. We can show or hide the rest of the machine as well by going back from machine to workpiece stock if we want to. And then, yeah, looking good. Here's one other thing. Let's do the fixture, and then we'll call it a day. So if we want to add, let's say we want to add soft draws on the 2 sides of the stock here. We're going to do that by going to Create 3D, going to Cube. Let's make a couple cubes on either side of the stock here. Excuse me. All right, so we're going to move the cube on either side of the stock. So we have to go with our origin, -2 inches. So that is right on the side there. And let's go down. I think we want to go down 1.5 inches at least. I mean, technically, we'd have to go down to the bottom if we're trying to profile a full profile. But let's just do this. So I'm making a cube. So I went to Create 3D. I went to Cube. I left it at the default parameters of length, width, and height of 2 by 2 by 2. And then the origin is x -2, y 0, z -1.5. And then I click OK. I'm making another cube on the other side of the stock by just changing the origin location from a -2 to a +2. So now I've got length, width, and height 2 by 2 by 2. Origin location is x2, y0, z -1.5, and I click OK. Now I can use those as my fixture by going to the CAM tree. And right below machine setup 1 in the CAM tree, you can see it says fixture. You can see that there's a red plus next to fixture, and the reason for that is because it is not selected yet. That's what a red plus means next to anything. So if I had removed the geometry of my feature, you can see that there's a red plus next to it, meaning that there's nothing selected for that. So it's a good tip there. You'll right click on fixture, reselect, click on the 2 solids and click OK. And then let's view the fixture in our simulation. So this is a great way to be able to view all of the components that you see at your machine and make sure everything is what it's supposed to be. To get the fixture moved up high enough, we have to do that work offset XYZ again. I'm trying to think of what the number would be. I think we'd be going up 1 inch extra. So to move all of this an extra inch above the table so that the fixture isn't sitting inside of the table like this, we just close out a simulation. And where's that found at again? That is found under machine setup. I right click on machine setup 1 and I go to edit. And then I scroll down, and instead of Z1 for work offset XYZ, I'm going to change it to Z2. So it should be X0, Y0, Z2. Those are the numbers that I want. So it's centered in the side of the table, but it's raised up so that the fixture is on top of the table as well. And then I click OK. And then I go to simulation. And everything should drive together now. Oh, we're still a ½ inch down. So close out of simulation. Go to machine setup 1, edit. Oops. Machine setup 1, edit. And let's do Z 2.5. So that is sitting right on top of the table. Got my math wrong there. Zoom in, and there we go. Perfect. So we have built, we created the stock in our milling job. We created the 2 cubes here and selected those for our fixture. And we went into the CAM defaults and selected all of these STL files to build our machine. When we close out of simulation, there's one more thing I wanted to think of highlighting. But as I'm thinking about what I was going to say, let me know in the comments section if you guys have any questions, comments, concerns. You guys learned anything today? You guys didn't learn anything today? Any kind of feedback is really useful for me, just to know that the methodology or the process that I went through with this is the right way to go for you guys. If not, let me know if there's anything that you got stuck on or anything that you had questions about going through the tutorial today. I want to thank everybody for viewing the live event today, going on how to build a machine. We do live events every other Wednesday. So today's the 9th of July. July 23rd will be our next webinar. We do one every other Wednesday, 1 p.m. Eastern Time. Topic is not yet determined yet, because we send out a survey and make sure all of these webinars are tailored to exactly what you want to see. Got enough people wanting to see how to build a simulation, so here it is. There was one other thing I wanted to mention about simulation and building the files, but it slipped my mind. As we mentioned before, you can go to File, Open, and you can open any of these STL files to see exactly if that was the right base file for us, and we see, okay, yep, that's the right one. Yeah, should be it. All right, let me know if you guys have any questions. I'll hang back for a second to answer any questions that you guys have. I want to thank everybody for viewing the event live today. And we've got a whole lot of different topics that we go over in these webinars. So on the support page that you're on now, you can see all of the other lessons that we've gone over in the past as well. Good question. Just a general question on simulation. What would cause the simulation window opening very slowly? Yours seemed to open pretty quickly. It's a great question. So if you are having any issues with stability with the software program, you might try to revolve the part around and it takes a while, or you try to open and close out of simulation every time, it could be pretty slow for you. It could even cause crashing. The first thing I mention is making sure that your computer is up to speed with our system requirements. So that is found right here. If you go to BobCAD.com, down at the bottom, you'll see the option for system requirements down at the bottom, sort of the middle of the page here. System requirements. It'll give you the minimum requirements over on the right-hand side. It'll say it requires a 2 gigahertz processor for your computer, either Windows 10 or 11, 8 gigabytes of RAM, and the main one here, the most important, is 1 gigabyte dedicated graphics card. And we're going to see if your computer has a dedicated graphics card now. So, and we're also going to make sure that BobCAD is running in that dedicated graphics card so that it runs as smoothly as possible. The first thing you have to do is you have to close out of BobCAD. So if you want to save this BobCAD1 file, go ahead and save it, and we'll close out of BobCAD. And then you go to your desktop. You right-click anywhere on your desktop here. Go to Show More Options down at the bottom. And then about halfway down, you should see this option, NVIDIA Control Panel. You'll either see NVIDIA, if you have an NVIDIA graphics card, or the other most popular graphics card is AMD. Those are the two dedicated graphics card options that you would see there. Most popular is NVIDIA. I think it's pronounced NVIDIA. Anyways, NVIDIA Control Panel, you'll click on that. And then it'll open up the window to the control panel of your graphics card to make sure that BobCAD's running in the graphics card so that simulation runs more smoothly. And it's taking a while to open, but here we go. Over on the left-hand side, the second option down, you'll click on Manage 3D Settings. And then in the main window here, you'll click on the second tab, Program Settings. And then you'll click Add. And then you'll scroll down and you'll find BobCAD B37 or whatever current version you're working in. You'll select it and select Add Selected Program down at the bottom here. If B37 is not already running in the graphics card here, you'll see an option down at the bottom right here that says Apply or Cancel. And you'll hit Apply so that you can apply those changes. I can't apply the changes because there's no changes for me to be had. So click Apply, and once you close out of the NVIDIA control panel, you reopen BobCAD, and it should run a little more smoothly for you. But yeah, if there's any other questions, please let me know. It's a great question because there's a lot of customers that ask about why is simulation not running smoothly? Why is the software program itself, when I do 3D modeling, not running smooth enough? That's a big reason why. There's some other troubleshooting options like making sure the driver is up to date for your graphics card and other options like that. But again, if you have any other questions with it, you can contact us at our support line and we can answer any questions that you have moving forward there. One other thing in the software program that could be useful for simulation is popping the simulation out to a separate window instead of the older way of opening it in the embedded version here. So to do that, you go to File and you go to Settings. And on the left-hand side, you'll click on CAM, and you'll change the simulation from an embedded window to a separate window. And then when you hit Apply and OK, I'm going to open up a part file that has some toolpath on it so that when I go to simulate, you'll see that the simulation opens in a separate window now. So I could put it on a second monitor, go full screen with it, and I can even multitask. So you can't see the simulation now. So if it's right here, make it a little bigger. I could run it and I can see, oh shoot, you know what? I did the wrong size for the holes. I go into BobCAD, you can see that it's fully workable now, right? You can go in and edit the milling operation or the drilling operation, change the tools, hit compute, and then you just reset the simulation here and hit run. So that way, as you said, your simulation window opens very slowly. Now you don't have to worry about opening simulation every time you're changing something. Leave it open. Then when you're changing all of your toolpath around, just go back to the window of simulation that's already open and then hit restart and run it from there. So that way you don't have to waste so much time waiting for it to open every time there. But great question. Great things to focus on there. I think that's what I was going to talk about actually, was the separate window for simulation. So answered my own question. All right, cool. So if you guys have any other questions, let me know. But other than that, I want to thank everyone for viewing the live event today, and we hope to see you in the next one, which is going to be July 23rd, 1 p.m. Eastern Time. Thanks again for viewing the live event today on building a machine. Whoops, I got one more question. Looks like my computer only has 36 configured. How would I add 37? Okay, so if you don't see 37 in the dropdown, we'll have to manually find it here. So let's go to Show More Options. We go to NVIDIA Control Panel. We go to wait on NVIDIA Control Panel to open again. We go to Manage 3D Settings. We go to Program Settings, and we go to Add. Got to make sure that you're clicking on Add because you're adding a new program. If you're just going through the drop down right here and 37 wasn't selected, you're not going to find it. So you go to Add, scroll down, and try to find BobCAD B37. If you don't see it here, then you can see down at the bottom, can't find the program, then you click Browse. Then you would find it under, where would you find it under? Is it right here? No. You find it under your C drive. Here's another weird file path for you again. So under your C drive, you go to Program Files, BobCAD-CAM, V37, and down at the bottom, here's your BobCAD application that you can click on and click Open. Now you've got it selected. If you've got to manually select it that way, that's how you can manually select it. But that's a good question. If the computer doesn't find it for you, you can find it manually that way. All right, great questions, guys, and I want to thank everybody for viewing the live event today. Again, if you have any other questions with compatibility with the software program, then you can call us or email us. Phone number is 727-489-0003. And email address is support@bobcad.com. Glad you guys were able to add the V37 there for your graphics card. Go ahead and test out simulation. Let us know if you have any more issues. If you have any more issues, just call us and we'll take it from there. And thanks everyone for viewing us live today. Hope to see you in the next one on July 23rd. All right, thanks again. See ya.